graphing v4 and v6, the old MRTG model, everybody uses MRTG and RRD to graph their octet counts. But the thing about those octet counts is they were all traffic, and there's no per protocol accounting. So now that we have IP version 4 and IP version 6, all you can see from the old octet count model is the total between them, and you cannot differentiate between the two protocols. There are various non-optimal things you can do, such as setting up ACLs on a router and feeding them, using them to feed counters. But so far, it's not as simple as it was with MRTG and IP version 4. You can still graph it with MRTG, but what you get is a graph of all traffic. This is a graph of all traffic, but I wrote tiny little programs, and I ran 8 instances of that program in order to listen on an interface and count octets for basic for 4 different types of traffic. The first one is v4, the second one is native v6, the third one is Teredo, and the fourth is 6-4. So this copy of this graph shows the v4 traffic dominating. It's obviously client-shaped traffic. The incoming is larger than the outgoing. We're sending small requests and getting big pages back. It's also got a diurnal hump. It's bigger in the middle than it is in the morning. So that indicates that traffic is highly influenced by the presence of people during the day, either because they're browsing the web manually, or because they come in and turn their machines on, and all the things their machines do automatically only occur during the day. So we'll go to the next graph, which is the same graph with v4 traffic excluded. And now Teredo is dominating the graph with a little 6-4 fuzz at the bottom. Teredo also has kind of a diurnal hump in it, so it seems that there's a lot of human presence related traffic in Teredo as well. 6-4 is not as clear about that. The native 6 is invisible on this graph. I don't even see a single pixel of native 6. But if we eliminate the tunnels, then we've got a picture of the native IPv6 traffic, which has a diurnal hump. It seems to be client-based. At the very bottom of the graph, there's a little green grass squiggly lines. So almost no outgoing traffic, larger incoming traffic. So it's probably web browser-based stuff. There seems to be a spike every 4 hours, all the way up to 5 kilobits per second. Now this isn't that impressive in terms of amounts of traffic, but you have to remember that the number of v4 sites that are out there to request pages from is many orders of magnitude larger than the number of sites that are out there to request v6 pages from. And that needs to change. So as I have said previously, one of the more important aspects of your v6 deployment is to make your outward facing services v6 capable. So you need to, and by doing that, you support the populations of people in China, for instance, and other places that have v6 only network. So the more v6 presence you offer to the internet, the more you support the deployment of v6 only networks in places that are address starved, that don't have enough v4 addresses. This is a comparison of given 2,504 hosts, which are pinged, which all have dual addressing and they have dual stacks on them across the whole internet around the world. These 2,504 hosts were pinged once with v6 and one with v4, and this is a derivation of the hop counts and the round trip time to those hosts. So what this shows is that from the perspective of the University of Hawaii, those 2,504 hosts around the world that are reachable by v6 have a slightly shorter hop count than v4, but a slightly longer RTT than v4 does. So it's actually not a big differential between the two. Here's a picture of the same thing from LavaNet. It's pretty much the same kind of result. The hop count is lower in v6, but the RTT is higher in v6, and it bears examination to figure out why that is, but luckily it's not terribly lopsided. So just this slide is just about all of the little things that you need to go check, all of the little details, the web server access controls, the ACLs, the firewall setups. I ran across PHP code, which was designed to return different content based on the IP address of the client, and of course it didn't know what to do with a big long string of letters and numbers with colons in it. So I had to change that PHP code to recognize a v6 address and address it correctly. Also, I've used MaxMind GeoIP in the past to identify where users of a certain web form were coming from, and this made the GeoIP returns the locations if the user was using a v6 address or came from a v6 address, then they were classified as having come from an undefined location. A couple of IPv6 deployment scenarios. First of all, you can consider setting up an IPv6 only network. Client support is sketchy. Translation is necessary to reach the IPv4 internet, and there is some value in enabling v6 only servers, which is kind of a side note. But the top two, client support is sketchy and translation necessary to reach the IPv4 internet, what's missing from client support is the ability to obtain a DNS server address. So you either have to have a Windows device which has DHCP6, or you can type it in manually, or for Linux and for Mac OS you can install a DHCP client so that you can get a server address. Of course, IPv6 only excludes Windows XP because Windows XP does not have the capability to get DNS information from an IPv6 connected DNS server. Dual stack is the three smiley one, which is probably what most people are reaching for at this point, and that's fine. It's deploying more IPv6 capable hosts in the world, getting your servers ready for IPv6. So as I said, you're facing that IPv6 only population and serving them through v6 instead of through a translator. For dual stack, client support is very good. If the client has v4 connectivity to a DNS server, it doesn't need to worry about getting a DNS server through v6. So XP is included in the dual stack scenario. There's no translation necessary between v4 and v6, whereas with the v6 only, if they're going to reach more than the very small number of sites that are currently connected on v6, they've got to have some way to reach the v4 internet. Also, dual stack serves potential v6 only groups and is relatively easy to implement. A downside is it requires IP version 4 addresses. If you don't have v4 addresses, then you dual stack in a native open real address scenario is going to be not a choice, not an option.